Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve.
I'm Scott.
Happy Monday morning to you. Researchers at the UC San Diego have developed a new wearable ultrasound patch for continuous and non-invasive blood pressure monitoring. And this patch is the size of your left thumbnail. That's how small it is.
Okay. I'm good with this.
It's pretty cool.
Yeah, I'm good with this.
The device is the first wearable ultrasound blood pressure sensor to undergo rigorous and comprehensive clinical validation on over 100 patients. Recently published in the Nature Biomedical Engineering, this technology could potentially improve the quality of cardiovascular health monitoring both in clinical settings and at home. This device, the size of your thumbnail. Would you like to know more?
Yeah, absolutely. So traditional blood pressure requirements or measurements with a cuff, which is, I don't know, you never know really where, if you're putting it at the right place, or I've heard you have to keep your arm down, you should keep your arm up, you should stand.
Are you rested, well rested, or just walk in? Yeah.
Yeah, there's so much variations, and it's weird. I mean, we'll talk about it after this. Which limits providing one-time blood pressure values. It can miss critical patterns, which I'm all about that. So our wearable patch offers a continuous stream of blood pressure waveform data, which that's cool too, right? Because I mean, you're exercising, you're doing stuff, you took your blood pressure in the morning, you didn't take it in the middle of the day, you take it in the afternoon, it's up high or low, whatever. I mean, it's just not consistent. So allowing it to reveal detailed trends in blood pressure fluctuations, said co-study first author Sei Zhao, who recently graduated with his PhD in material science and engineering from UC San Diego Jacobs School of Engineering, which this is not something that I would have thought that they would have been involved in an engineering school, but it's all good.
Yeah.
The patch is a soft and stretchy device about the size of a postage stamp, like you said, that adheres to your skin. When worn on the forearm, it offers a precise, real-time readings of blood pressure deep within the body. The patch is made of a silicone elastomer that houses an array of small, piezoelectric transducers.
Sounds good to me.
Sandwiched between stretchable copper electrodes. The transducers transmit and receive ultrasound waves that track changes in the diameter of blood vessels, which are then converted into blood pressure values. Could you imagine? You could be wearing this as an athlete, military, military, out in the field, doing drills, exercising, just people that are susceptible to high blood pressure. This is game changing, man. This is really cool. It reminds me kind of that the patch that people wore for maybe they still do for smoking.
Nicotine patch.
Yeah. So.
Yeah. So this probably you download the telemetry on your phone. You probably just hold it right up next to the patch and all gets downloaded. It's pretty cool. The wearable ultrasound patch builds upon an earlier prototype pioneered by the lab of Sheng Zhu, a professor in the Aisu Yufeng Li family Department of Chemical and Nano Engineering at UC San Diego. So it's two departments working together. Researchers re-engineered the patch with two key improvements to enhance its performance for continuous blood pressure monitoring. First, they packed the piezoelectric transducers closer together, enabling them to provide wider coverage so they could better target smaller arteries, such as the brachial and radial arteries, which are more clinically relevant. Second, they added a backing layer to dampen redundant vibrations from the transducers, resulting in improved signal clarity and tracking accuracy of arterial walls. Fascinating.
Yeah. So in tests, the device produced results comparable to those of a blood pressure cuff and another clinical device called an arterial line, which is a sensor inserted into an artery to continuously monitor blood pressure, maybe like what they do in a hospital setting or something like that.
Yeah.
What the arterial line is the gold standard for while the artillery line is the gold standard for blood pressure measurement in intensive care units, and there you go, and operating rooms, it's highly invasive, limits patients' mobility, and can cause pain or discomfort. The patch provides a simpler and more reliable alternative, as shown in validation tests conducted on patients undergoing arterial line procedures in cardiac catheterization laboratories and intensive care units. Yeah, and I'd be involved in some kind of a trial for one of these things. So I'm sure they've got them going on.
I think they're going to expand the tests for this. Researchers conducted extensive tests to validate the patch's safety and accuracy. A total of 117 subjects participated in studies that evaluated blood pressure across a wide range of activities and settings. In one set of tests, 7 participants wore the patch during daily activities such as cycling, raising an arm or a leg, performing mental arithmetic, meditating, eating meals, and consuming energy drinks. In a larger cohort of 85 subjects, the patch was tested during changes in posture, such as transitioning from stand up, sit down, fight. Yeah. Results from the patch closely matched those from blood pressure cuffs in all tests.
Okay. The patch's ability to continuously monitor blood pressure was evaluated in 21 patients, so I guess I'm too late for that trial, in a cardiac catheterization laboratory, and 4 patients who were admitted to the intensive care unit after surgery. Measurements from the patch agreed closely with results from the arterial line, showcasing its potential as a non-invasive alternative. Quote, a big advance of this work is how thoroughly we validated this technology, thanks to the work of our medical collaborators, said Zhu. Blood pressure can be all over the place depending on factors like white coat syndrome, I'm down with that, masked hypertension, daily activities, or use of medication, which makes it tricky to get an accurate diagnosis or manage treatment. That's why it was so important for us to test this device in a wide variety of real-world and clinical settings. Many studies were on wearable devices skip these steps during the development, but we made sure we covered it. So these guys are all about it, man. This is cool.
Pretty thorough too, the collaboration between the engineers and the medical.
Yep.
So the research team is preparing for large-scale clinical trials and plans to integrate machine learning to further improve the device's capabilities, like AI. That's awesome. Efforts are also underway to validate a wireless battery-powered version for long-term use and seamless integration with existing hospital systems. That's pretty cool too.
Yeah, sign me up.
Yeah.
Sounds pretty cool.
Really cool technology here. Yeah. All right, folks, we appreciate you joining us this morning. We've got some more for you this afternoon. Stay tuned. We'll talk to you later.
All right, take care, everyone. Have a good day.